So here I'm on graphing hyperbolas. We want to go on page 1. And when you look at this thing, the working form equations is what we've been dealing with. Let's do a quick review. If you remember right, for circles, the working form looked like x minus h squared plus y minus k squared equals r squared. For ellipses, which are square circles, it was x minus h squared over a squared plus y minus k squared over b squared equals 1. You notice both of these, we are adding both of these terms. Okay, hyperbolas are going to look very similar, especially to ellipses, except that one term is negative. All right? Or they're going to have opposite sides. And this is an important note right here. When graphing, it really is helpful to use these a and b values. And you're going to find the a value under x, but that's squared. The b value under y, it is also squared. And so what you want to do then is always draw a and b. And again, like anything, your center is going to be in the middle here, but with the opposite sign. So in that respect, it's very similar. So the first thing you want to do is draw your center, and then find A and move A in each direction and B in each direction, and then draw a square. And you notice that our asymptotes, which are these things right here, go through the corners of the boxes. And our vertices will occur either here or here. Okay, so let's look at a couple of examples of what these guys look like. Oh, too far. We'll leave our picture up. All right, let's take a look at the one on the left first. And as you can see, here is our working form of our equation. All right. Now, you notice that the x term here is positive. Which means this thing is going to open sideways. And, oh, forgot to remind you, hyperbolas, remember these are the ones where we taped the two cones tip to tip and then cut down the middle. And so you're seeing the cut of one cone here and another cone here. The center is going to be in HK. All right, H you find in the X term, K you find in the Y term, and you change the signs of them. All right, on the sideways one, this point here and this point here are your vertices. Okay, and this is also a vertex. Okay, so your vertices are going to occur where the curves intersect our box. And you can see the little box in here, where this then is going to be A and this is going to be B. So the vertices on this thing are going to occur at H plus A, K, and at H minus A, K. In other words, I'm going to move to positive x direction from H and then negative x direction from H, and my y value does not change. This point right here at the box intersects up here is what's called the co-vertex. And we've got another co-vertex right here. And these things are really only important in getting the equation and in getting the asymptotes. And the co-vertices, as you can see now, we're moving vertically, so they're both going to be at H. But I'm going to have one which is going to be a K plus B, and another one which is going to be a K minus B. Okay, the asymptotes, these are lines. My asymptotes are going to occur at, and I've got two of them, and they're going to have opposite signs. So one will be a plus, the other one will be a minus. The slope is going to be B over A, which is our rise over our run. Okay, we're going to rise B and run A on the positive one, and then we're going to rise B and run a negative A on the other one, which gets us the negative one. And then it will be H minus, X minus H. It's going to be B over A, then X minus H plus K. And this gets us the equation of our asymptotes in point slope form. And again, to graph these things, it helps to have the box on here. Okay, so that's one opening sideways. Let's take a look at this thing. This is a little different now. Our A's and our B's are still the same. But you notice this thing's opening up and down. There's a vertex, and there's a vertex, because it's where the curve intersects them. And this is a and this is a vertex. Okay, so again, notice that X term, now let's do this differently. Here the Y term is positive. So if the Y term is positive, this thing is going to open up and down more vertically. So remember, if the X term is positive, it's going to open sideways, right and left. If the Y term is positive, it's going to open up and down. Our center is still H and K. Now my vertices are a little bit different because now we're moving along the y-axis to get to them. So my vertices are, both of them are going to be at the x value of H. But on this one, I'm going to take my K plus B, and I'm going to have my K minus B. And as you can see, this is basically our, that should be K minus B. Well, where my vertices on the horizontal one are now my co-vertices on the horizontal one are now my vertices. And again, these points are the same, it's just that when your Y term is the one that's positive, it opens up and down, and so you switch what's a vertex and what's a co-vertex. And my co-vertices now are going to be at H plus A, K, and at H minus A, K. But again, don't make a real big deal out of all of this. It's basically the same thing that we had before, except that said these points are the same spot. It's just whether or not the thing opens up and down or right and left as to whether we call it a vertex or a co-vertex. And the equation for the asymptote is exactly the same as it was for the other one. It's going to be y equals plus and minus, there's my 2, 1, b over a, that's my slope, is going to be x minus h plus k. And that's the equation for my two asymptotes. Again, they're the same as what we had before. All right, so let's take a look at this guy then. Tell the features of each hyperbola. The center, all right. The center is obviously where our two asymptotes intersect, all right? And this is going to be important on page 4. My center on this one is at 0, 0. My A is the direction from my center to my vertex as I move that direction. So it is 2. And my B will be going up. And you can see they kind of got their little box drawn here. And so we go up 3 to get to that point. So my vertices now are going to be at H. Remember, my vertices for opening right and left, which is what this one is, are going to be H plus A and H minus A. So they're going to be at 2, 0, which is H plus A, and at negative 2, 0, which is going to be H minus A. My covertices, both of my x-coordinates will be 0 here. That's these guys. And then they're going to be at K plus B and at K minus B. My asymptotes, all right, are going to be, if you remember right, we were dealing with plus or minus B minus A. Now my H and K are both 0, so they're not going to enter in here. So my asymptotes are going to be B over A. So I'm going to have 3 over 2, and this would be x minus 0 plus 0, which is y all you're seeing. And then I'll have a negative 3 over 2x. And the equation of this thing then is going to be, and let's start at the top, so I'm going to have x minus 0 squared. Now, my x is positive because this opens right and left, so I'm going to have a minus y squared. Thing will be equal to 1. And then this will be over, my x term will be over a squared. That will be 4. And my b term is over b squared, which will be 9. Okay, so now let's come over and look at this one. You notice this opens up and down. And also I've got my center moved from where we had before. So my center here now, which is where my two asymptotes intersect, is going to be at x is 3 and y is negative 2. Then if I count over to my vertex, my A is 1 and my B is going to be 1, 2, 3. Okay, now my vertices here, if you remember right, on this other one, we just moved in the x direction. Here, we're going to move in the y direction. So my center is not going to change in either one of these. It's going to stay as 3. But on one of them, I'm going to take my k value and add b. So negative 2 plus 3 gives me 1. Then I'm going to have a negative 2 minus 3, which will give me a negative 5. And then my covertices then will be these guys over here. And so my y value is not going to change anymore. And now I'm going to take my h value. I'm going to add 1 to it. So I will have a 4 negative 2. And then I will take my h value and subtract 1 from it, which will give me a 3 negative 2. So my asymptotes. Now, because my center is no longer at 0 and 0, we're going to have to fill in all of our terms. It's going to be y equals plus and minus. If you remember right, it's b over a, so 3 over 1 gives me 3. Then I'm going to have x minus h, which is 3. And then we had the plus k, which is a negative 2. And we added a negative 2. And those are the equations for my two asymptotes. And the equation we are going to get, because this opens up and down, and in the example they gave you where they put the x term first, I always like to write my y term first. So let's do our minus. Now everything is going to equal to 1. My x term, so I'm going to have x minus 3 squared over a squared, which is 1. And then my y term is going to be my positive 1. So it will be y plus 2 squared over y squared, which is 9. And I've got my minus in between there. You notice in the example, they wrote this as a negative x minus 3 squared plus y plus 2 squared over 9 equals 1. And these are equivalent expressions. I just prefer to keep my positive term up front, but I will accept it if you write it this way. Okay, so now I want you to pop over to page 4 real quick. All right, let's take a look at number 6. We've got a hyperbola here, and you're going to do number 7 as homework. Pages 2 and 3 are also work. So all we've got is a hyperbola that opens right and left, and they give us our asymptotes. We need to find the coordinates for the hyperbola's center. And he knows hyperbola's center is where they intersect. And if you remember right, this is what we did before. So we need to solve this system up here for these two. We find where they intersect. Because they're both y equals, we basically set these equal to each other. We end up with 2x minus 14 equals negative 2x plus 2. And then I solve this, I add 2x over. That gives me 4x. And then I add 14 over here. Equals 16. Or x equals 4. So there's my x coordinate of the center. And then to find my y coordinate, I just plug it back in. My y coordinate then will be equal to 2 times 4 minus 14, which is 8 minus 14, so that's going to give me a negative 6. So my center then is going to be at 4, negative 6. All right, now we want to find the vertices, which is x and y. And if you remember right, the slope here, our slope for these, was a plus and minus b over a. And since we're just given a 2, we need to know something about what a is. So what I do know is my slope is 2, and that's going to equal 2. I'm just going to deal with my positive 1. And they said a is going to be 5, so I'm going to have b over 5. And to solve for that, because I'm dividing by 5, I want to multiply both sides by 5, which is going to give me b equals 10. All right, and if you remember right, we're going to move right and left, and they gave you b as 10 over here. So my vertex then is going to be h plus or minus a and k. So my h is 4 from up here. So I'm going to have a 4 and my a is 5, so I would have a 4 plus 5, which will give me 9, and my y is negative 6. And then I'm going to have 4 minus 5, which will give me negative 1, negative 6. And they're my two vertices. And as you can see, I went ahead and showed you how to solve for b equals 10. And you do the same thing here. Now here your x coordinates don't change because we're dealing with these points for our co-vertices. So x is going to be 4, and then it's going to be k plus and minus b values. So one point then will be 4. My k is negative 6. So negative 6 plus 10 gets me 4. And then my other point will be 4, and it will be negative 6 minus 10. So that will be a negative 16. And this problem right here, you're going to work in class. And these are the notes for graphing hyperbolas.